Moving on from the stomach, we're moving into the small intestines. Now, the small intestines is really where the majority of absorption is going to be occurring. So it's really kind of like the major organ of your GI tract. It ranges in length anywhere from 7 to 13 feet. And you might be thinking, that's a large range. Well, yeah, it happens. It depends on each individual person. But that's going to start, that initial start of the small intestines starts at the duodenum, which is the first of the 3 divisions, or 3 regions. So at the end of the stomach is the pyloric valve. That then goes in the duodenum. Then the jejunum, then the ileum. Watch the spelling of ileum, I-L-E-U-M, E for eating, I-L-E-U-M. Now after the ileum, you have this ileocecal valve. The ileocecal valve is the separation point between the small intestines of the ileum and the large intestines. So 3 different regions of the small intestines. So the small intestines is the organ, duodenum, jejunum, ileum are the regions of the actual organ. So if looking at this diagram, you can see you have the duodenum is where things start, that's up top. You then end up in the jejunum in the middle, and at the very bottom is where the ileum is. That ileum is going to lead into the small, actual large intestines right over here. So you have that ileum leading right into the large intestines. So looking at the duodenum, we'll start at the beginning. In the duodenum, you're going to have the bile duct and the main pancreatic ducts both coming into the duodenum at a single point. They're both going to join together and enter the duodenum at the major duodenal papilla. And I'll show you this in a picture in a second. That's the junction point where they're entering into the duodenum into the actual small intestines. That's controlled by the hepatopancreatic sphincter. So this sphincter will open and close, allowing these 2 different ducts to secrete their fluids into the actual duodenum. Now, this is important because the main pancreatic duct is going to have a whole series of different enzymes coming through. The bile duct is where you have bile from the liver and the gallbladder. Both are vital for the physiology of how digestion occurs in the small intestines. So while there's a lot of things labeled here, we're focusing right down here. That is where you can see the major duodenal papilla. Now inside that major duodenal papilla, this section right in there, that's where the hepatopancreatic ampulla and sphincter are found. You can see how you have this green one up here. That's going to be your bile duct coming down. And then you can see over here is the main duct of the pancreas coming down. So that's a very important point to kind of keep track of because that's where all these enzymes and chemicals are coming into the duodenum to help out with digestion. Now, there's some other structural modifications inside the small intestines. Well, the stomach had rugae, those kind of folds. There's a different type of fold in the small intestines. We're going to have these circular folds, which kind of create this spiraling effect. You can almost think of a slinky. Imagine if you just stretched a slinky out a little bit, you can follow that line moving forward and rolling through. It's not just a single circle. It's kind of tilted, so they keep going over and over and over. Those are the circular folds. And on those circular folds are villi. On the villi are microvilli. So let's take a look. In this image, you can see how you have these actual folds here going around. Those folds are just like a slinky. They're meant to be propelling. It slows the chyme down. It allows the chyme to go into these folds and travel along this route. It's helping to maximize surface area. And then on each one of those folds, you can see these little tiny projections coming out. Each one of those projections is a single villi. So you have those increasing surface area. The villi help to increase the surface area even further beyond the circular folds of that. Now, these villi themselves, only about 1 millimeter high. They're tiny little things. But those tiny little things are helping to create an increased surface area of the mucosa. Now, the actual epithelium, Simple columnar, great for absorbing, because the idea here is you're trying to absorb the nutrients, absorb the water, absorb the vitamins, absorb the minerals. You're absorbing things out of your intestines. But you also have goblet cells. Goblet cells are producing mucus. Mucus is helping to lubricate the entire tract, helping make sure that those particles are all moving down those circular folds. So it's all working together to increase surface area. The mucus then helps to lubricate everything, while the simple columnar helps to absorb all the nutrients that we can absorb at that time. So again, each one of these is going to be a villus, in plural villi. Those are helping to increase surface area. But we still have those microvilli. The microvilli are these tiny little projections. Now that's a blow up of just that little box over here. So that means those are tiny little projections just on the surface of each simple columnar cell. So further increasing surface area. So we've increased surface area with the microvilli on the actual cell surface. Then the villi here, these finger-like projections, increase the surface area further, and then those circular folds help to increase it even further beyond that. All about trying to increase surface area. Now, these microvilli, these projections, are also called sometimes the brush border. And these brush border can contain or secrete, in some cases, different enzymes. They're referred to as the brush border enzymes. So we'll come back to those a little later when we start talking about the physiology of this. But keep in mind, those microvilli, that brush border, will be secreting some enzymes to help out with the digestive process. All right, switching gears. Now this also increases surface area, but the purpose isn't really to help increase surface area for absorption here. We have these intestinal crypts. They're kind of indents that go down into the mucosa. So while those villi stick up, finger-like extensions, the crypts go down inward. They contain enteroendocrine cells. They contain interepithelial lymphocytes. Well, the enteroendocrine cells we talked about. These IELs, we haven't yet. What's interesting is these actual interepithelial lymphocytes release cytokinins. They're all about trying to kill off infected cells. Get rid of bacteria, get rid of infected cells of the actual crypt. You're trying to protect the mucosal lining. You also have Paneth cells, secreting antimicrobial agents. These are things like lysosome, things like defensins. The idea is you're trying to get rid of bacteria. Think back to the lymphatic chapter. We talked about the tonsils. How the tonsils have those indentations that trap bacteria. Same idea here. We're trying to trap bacteria. You have antimicrobial proteins down here. You have the lysozymes. You have these IELs. They're all trying to get rid of any infections, trying to protect your intestinal lining. So we've already looked at the surface area increase with the villi and microvilli, but notice down here, that is the intestinal crypt. It goes down into the actual wall of the intestines. So it's all going to have those enteroendocrine cells plus those Paneth cells in there trying to make sure it's safe, trying to keep the lining healthy. Now, the submucosa, while that crypt goes down as epithelial, which means it's mucosa, the submucosa is a layer below that. We're going to have two different things here. We have these Peyer's patches and duodenal glands. Peyer's patches, we've mentioned before. Peyer's patches are going to be lymphatic tissue, part of MALT, mucosal-associated lymphatic tissue. They're found down at the distal part, so distal further away. But these duodenal glands, known as Brunner's glands sometimes, they're secreting a mucus solution. They're helping to increase the mucosal content inside the actual cells. So by having more mucus be secreted into the lumen, It's aiding the actual goblet cells of the mucosa to make sure you have enough mucus in the tract to allow those particles to propel down the small intestines. So we have these duodenal glands increasing the mucus content inside the lumen. So a little more about how and helping this case is doing. It's helping not only for immune function, but helping with mucosal secretion. So small intestines, a lot more to discuss, but just a little about how it's structured and how it's built for the basic functionality to increase surface area and to fight off infections by using those intestinal crypts.